The game of Yahtzee is played with 5 dice. A Yahtzee occurs when all 5 dice are the same number. You also have more than one roll, and you may choose to not roll some of your dice. Our first question is, what's the probability of getting a Yahtzee on your first roll? And our second question has us setting aside 2 rolled 3s. The question is, what's the probability of rolling a Yahtzee on the next roll? Part A doesn't rely on any new material. Instead, we just need to count the number of ways we could have a Yahtzee divided by the number of ways to roll 5 die. In this case, our denominator is 6 times 6 times 6 times 6 times 6. And our numerator is also 6, coming from the fact that they could either all be 1s, they could all be 2s, they could all be 3s, they could all be 4s, they could all be 5s, or they could all be 6. So our final answer is 1 over 6 to the 4. Our part B involves conditional probabilities. The numerator of our fraction will be the number of ways to get a Yahtzee and at least 2 3s, divided by the number of ways to have greater than or equal to 2 3s. Our numerator in this case might actually be the easier one to count. The only way to have a Yahtzee, in which case all 5 dice are the same, and to have 2 of them be 3s, is for them all to be 3s. This means there is only one option for what it can be. Here, our denominator, if we know that 2 of them are 3s, then the question is, how many ways for the other 3s to be rolled? There's 6 ways for the first of the other 3 to be rolled, and 6 for the second of the other 3 to be rolled, and another 6 for the last to be rolled. So our final answer is 1 over 6 raised to the third. So you're only 6 times more likely to roll a Yahtzee knowing that you've rolled 2 3s than to roll a Yahtzee on your first roll. Our next example involves a marble collector that has 3 green, 4 red, and 5 blue marbles. You will be blindly choosing 5 marbles. Part A asks, what's the probability of getting all green? In Part B, imagine that you cheat and peek, which guarantees that you get at least 1 green marble. And it again asks, how likely are you to get all green? Again, Part A doesn't require any conditional probabilities. The denominator is all of the ways to choose 5 marbles. Here, since there are 12 marbles to choose from, this is 12 choose 5. Our numerator is all of the ways to end up with all of the greens. So choosing our 3 greens from the 3 is 3 choose 3. Here we want to choose from the remaining 9, 2 more. This works out to be 1 over 22, which equals 0.045, the 4-5 repeating. Our part B does require conditional probability. It's asking the probability of 3 green given you have at least 1 green. Here our numerator would be the number of ways to get 3 greens and at least 1 green, and our denominator would be the number of ways to get at least 1 green. In this case, if you get 3 green, then you will also have gotten at least 1 green. So our numerator will just be the number of ways to get all green marbles, which should look familiar as 3 choose 3 times 9 choose 2. Here our denominator is different though. Remember that the number of ways to have at least 1 of something is equal to the number of ways to get all general hands minus the number of ways to choose 5 marbles and have 0 green marbles. Here the number of ways to choose 5 marbles is 12 choose 5 minus 0 green marbles, which means we chose 5 marbles from our 8 non-greens. This works out to be 736. So the denominator of our part B question is 736. Our numerator is 84. In its greatest reduced form, this is 21 over 184, which is approximately 0.114. Comparing our answers, we see that cheating to guarantee at least one green more than doubled the likelihood of ending up with all of the greens.